So today we're going to have an intro to modular congruence. But first, let's have a quick revision on division. So if I divide x by y, I have a quotient q, and it has remainder r. That's just the normal division of integers, right? So this is called the dividend, and this is called the divisor. Okay, so let's just come up with an example. Let's just say 14 divided by 6 equals 2 remainder 2. So the quotient is 2 and the remainder is 2. This means that 14 can be written as 6 times 2 plus 2. So let's do another example here. Let's say it's 20 divided by 6 equals 3 remainder 2. So you can do this on your own, and 20 is represented therefore by 6 times 3 plus 2. So what's something the same between the two equations here above? Well, clearly they are both divided by both of the dividends are divided by the number 6. And that's the first similarity. The second similarity is that they both have the same remainder. So when two numbers are divided by the same divisor and they both have the same remainder, we say that they are modular. They're modular congruent. So therefore, basically, you can write 14 is congruent to 20 mod 6. So what does this mean? It basically means, so 14 is congruent to 20 mod 6, meaning 14 divided by 6 has the same remainder as 20 divided by 6, which in this case is true. If this isn't true, let's say it's 14 and 21 mod 6. So this isn't true because 21 divided by 6 has a remainder of 3, not 2. Then you put this diagonal line over here. You say 14 is not congruent with that 21 mod 6. Okay, so right now our definition for modular congruence, for two numbers to achieve modular congruence, is that when they are divided by this number, which is called the modulus, when they are both divided by the modulus, they have the same remainder. That's our definition for modular congruence. However, what if I told you there was a new definition that involves the entire scope of integers? So right now it looks like this only includes natural numbers, because natural numbers and 0, because negative integers don't really look like they have a remainder. So what if I told you that a new definition was that if A was modular congruent to B mod C, this is only true if and only if. So this is only true if and only if A minus B is a divisor, A minus B is a multiple of C, so C is divisible by that. So what if that's what I told you? That's the new definition for modular congruence. If this is true, A is modular congruent to B mod C. Well, let's try it out then. The two definitions are essentially interchangeable, except for this one covers negative numbers as well. Okay, so let's come up with an example. Let's just still use the 20 and 14 divided by 6 one. This means that we want to know 20 minus 14, or actually in this case 14 minus 20, because here A is 14 and B is 20. 14 minus 20, is that divisible by 6? 14 minus 20 is negative 6. Negative 6 divided by 6 is equal to negative 1. Now by divisible, I mean by the quotient is so the quotient is an integer. It doesn't have to be positive or zero. It just has to be an integer. So negative is okay. So there's no remainder, and the quotient is an integer, meaning that negative 6 is a multiple of 6. So 14 and 20 are modular congruent mod 6. Okay, so that's just the basics for modular congruence. Thanks for watching, and bye.